Welcome to another episode of Well, Don't Tell the Kids. I'm Janet Lee, your host, and today my guest is Dr. Nicole Woitowich. Thanks so much for joining me today, Nicole.
Thank you so much for having me.
Nicole joins us for our conversation from the windy city of Chicago in Illinois. Just by way of introduction, are you a Midwesterner, born and raised, or?
I am a Midwesterner, and I am a local Chicago native as well.
Kind of wanted to start how you first became interested in, I believe you studied biology first?
Yes. So I received my undergraduate degree in biology from Purdue University. Then I came back to Chicago, where I got my master's in biology from Northeastern Illinois University. And from there, I went on to Rosalind Franklin University of Medicine and Science, where I obtained my PhD in biochemistry and molecular biology.
Did you study something in particular at the bachelor and master's level in biology?
In the master's level, I was very focused on protein structures unfolding. So I used a tool called X-ray crystallography to study the structure of different bacterial proteins. And so going into my PhD, I thought I really wanted to continue that work in protein structure. But as I think we'll talk about in a little bit, I found that I really had a passion for working with women in STEM and communicating science more so than I had staying at the benchtop.
That segues into the next section here. You're currently the Director of Science, Outreach, and Education at the Women's Health Research Institute at Northwestern University. Is that right?
Yes, that is correct.
And that's affiliated with the Feinberg School of Medicine?
Yes, we are housed within the Feinberg School of Medicine.
You said you made a shift from doctoral work in biochemistry over to where your current interest is. Did something seminal occur that made you like, oh, I definitely want to switch, or was it more of an evolution?
So when I was in graduate school, I really tried to explore different career opportunities just because I know the career trajectory for research faculty and research professors is very competitive, and so I wanted to be a very well-rounded candidate. And so in my quest to obtain other sorts of, let's say, CV-building things, I really got involved with promoting women in STEM, and I kind of fell into that just because where I went to graduate school, there was a lack of programming for young women interested in STEM. And the community that surrounded my graduate program was a socioeconomically depressed community, a lot of groups that are traditionally underrepresented in the STEM fields. And so I decided to start a little program while I was a graduate student that would give students in the area the opportunity to come in and learn about the different types of way you could be a doctor, from a medical doctor to a PhD.
Does that have a name?
Yes, that was called Women in Scientific Discovery or Medicine, and so the name was Wisdom. That was a very enriching. So that was a very enriching program, and I got a chance to work with some of my colleagues, one of which is now my colleague both from graduate school and now at Northwestern, Dr. Sahidi Pamarthi. She collaborated with me on that project, and that was a really kind of the turning point in my career when I realized I really wanted to pursue a career in outreach and education.
Wow, I've spoken to several people so far on this podcast, and a lot of people come to the service or the community service aspect of it decades later from where you it seems to be a starting but jumping off point for you. You are a self-described champion for women in STEM being science, technology, engineering, and math, and you'd like to develop programming which promotes advancement and retainment of women in science and medicine. What have you seen as the biggest challenges to women in these STEM fields? And you touched upon ways to create, significant change. I'm just curious to hear about your viewpoint.
So I really kind of take a look at this question as in two parts. So I think one of the first challenges that young girls may face in the elementary and early high school time period is that lack of role models, not having access to women who are doing careers that they may be interested in, and having that face-to-face communication with people who look like them doing what they would like to do. Our typical representation of a scientist is usually sort of the Albert Einstein, a guy in a lab coat with some crazy hair. And the reality is that is quite different, and there are scientists that come from all different kinds of backgrounds. And so I think the first part is getting young girls excited about science, and then getting them to realize that this is an opportunity for them. Now, that becomes a different sort of problem once you have women who have entered college and graduate school. So research by the National Science Foundation shows that we have about equal rates of women graduating with degrees, and I'll speak specifically to the life sciences. It's about 50-50 in undergraduate and graduate degrees. But there's really quite a sharp decline then as women proceed in academia, as they tend to drop off at the full professor ranks as well as department chairs or other positions of leadership within academia. So I think that is a different approach of how we can maintain women in the pipeline. And Northwestern University and the Women's Health Research Institute has established some programs to support women in the academic pipeline.
How old are these programs? Far back do they go? I'm wondering have you seen any improvement?
So I think that's a little bit too hard to tell with the ones that we are running currently through the Women's Health Research Institute. But I think one of the most important things, no matter what institution, is creating a culture of inclusivity. And so having family-friendly policies, supporting women, providing child care, and that goes for both men and women, are just some of the examples that can make a department or institution more inclusive, along with transparency in hiring and promotion policies.
In the private sector, I just read a little article on a networking site, and it was from Deloitte consulting firm. And they are actually doing away with a long-standing program where they have people of minorities. They're getting rid of that and then making more of inclusion panels where they would also include the white males. Because STEM was started as a program for women and minorities to get them involved. And I guess my thoughts run towards effectiveness. It's been around for a couple decades.
And so I think that's a large problem in a lot of what we do in outreach. We don't have concrete markers of success. We can track students through, grade school to high school to college and so on and so forth, but we have a really hard time developing metrics to evaluate our success other than essentially, quite frankly, surveys and the hard numbers. So that's, I guess, one of the biggest problems with developing these sorts of outreach programs is creating the right set of metrics to gauge our effectiveness.
Intriguingly, you also self-describe or mention that you utilize both traditional and non-traditional science communication methods to educate investigators on the importance of sex and gender inclusion in biomedical and clinical research. Can you tell us a little bit about the differences between the traditional and non-traditional communication methods that you're working with?
So that's a really great question. And so one of the things that I think people get surprised about is that do scientists also need science outreach? And the answer would be absolutely. A lot of us tend to talk to our colleagues in our own field, but then do not tend to talk amongst ourselves. And so the Women's Health Research Institute really champions sex-inclusive science, meaning that we encourage investigators to consider sex as a biological variable, just as the 2016 NIH policy does. And so for some investigators, this might be the first time since the implementation of that policy that they've had to work with, say, male and female animals. And so we've created a variety of educational programs to communicate with investigators about this issue. We offer hands-on training, but I think, some of the other methods we use, blogging, we use social media. Yes, exactly. Podcasts and I know other scientists have done these podcasts as well, just to try to get people to engage with this idea of sex-inclusive science.
Well, I find that shocking that last year, an indicator that that's legislated to do this, I just assumed that it had been done in the past. I assume that mostly the male animals used. Is that the general protocol?
Yes, historically, male animals were used for a lot of research studies or cell lines. Now, we know that depending on where the cell line comes from, that cell should have an X or a Y or a chromosome, and so we also have sex for our cells. And so what the problem became was either researchers were using only male cells or animals, or perhaps the larger problem, they were not reporting what sex they were using in their experiments. And so without going into too much detail about the issue, this really creates a problem when we're trying to look for sex-specific problems or solutions to problems, especially in the era of personalized medicine. If we're not accounting for half the population at these stages of basic research, this just becomes more costly and time-consuming when it gets to the point of the clinical trial.
So if I talk to one of the 90% of folks that are doing it this way, what would they say to me? I say, well, why aren't you looking at male and female lines?
So I think some of the issues with animals may be cost, so having to have both groups of male and female animals. And then another one is having to look at hormones in female animals. And so one of the most commonly used animal models in science is the rodent model. And so just like women have a menstrual cycle, female rodents have an estrous cycle, and so they too have periods of low estrogen versus high estrogen. And depending on what you're trying to study, that may have an influence on the outcome. So not only do you have to study, not every study will have to do this, but you may want to look at male animals and then female animals at different points in their estrous cycle. So that just leads more resources, and investigators may find that as challenging for some.
Well, I come from an engineering background, and so we like to say sometimes, well, that's not a bug, that's a feature. So if they're going to research things like that, then it sheds more light on the problem.
That's correct. But unfortunately, you can't leave out one of the variables that's half of the human population.
Currently, your research focuses, as you've been saying, on the implementation and incorporation of sex as a biological variable within the U.S. biomedical research enterprise, attitudes and support structures of women and academia. Any advice, especially for young women, advance and move into the STEM fields?
Absolutely. I think one of the decisions that was critical for me staying in the sciences was finding a mentor. And so, I, and I'm sure like other students early on in their career, I struggled to really figure out what I wanted to do or how I wanted to get there. And I really owe all of my successes to identifying mentors early on in my career, especially during my master's program. These mentors really helped me kind of set me on the path for success, and without which I don't know if I would be here right now. I like to tell a lot of students before I really got into the field, I was working at a metal manufacturing company. And I was working as an administrative assistant, and I really didn't think I was smart enough or good enough to become a scientist. And so it was the encouragement from mentors that really kind of helped me succeed and endure throughout my career so far. And I think my second biggest piece of advice is, I say mentors plural. I always encourage that women establish a mentorship team, and that can include people from all different varieties and backgrounds, and it can also be peers as well. It doesn't always have to be somebody who is a little bit more advanced than you. It could always be a near peer. So
when you say mentor, I immediately go to the professor, so an advisor. What's the best way to approach?
So that's a good question. So a mentor, we do refer to our supervisors in sciences as a mentor, but not all of our supervisors are great mentors. So I encourage individuals to find people who is somebody who will talk to them openly about their career, and who will perhaps advocate on their behalf. I think that's one of the great functions of a mentor, is that they're willing to advocate and sort of be your champion. And so this may not be your direct supervisor. This may be somebody in your department. This may be a coworker who perhaps has a different set of experiences compared to you. And then I also encourage, kind of going outside of your field, maybe getting somebody who has a little bit more distance to also provide a little bit of perspective.
And just shifting gears a little, so thinking back over your experience, has there been any bench disasters in the lab or any odd moments that you'd care to share?
Oh gosh, I can't tell you how many mistakes I've made. And hopefully that's not the reason why I left the bench. But no, you know what? That's the beauty of science, is that sometimes things don't go the way as planned. During my graduate training, I had experiments that, we were trying to get them to work for several months, sure. And, they just didn't work out. But I have had my fair share of blunders, equipment failures, wrong orders, and you know what?
Have you ever had to use that shower thing? You pull
no,
and they come loud.
Luckily, I didn't. I've never had to use any sort of, the safety shower or safety eye wash or anything like that.
Escape animals.
Oh no escaped animals. No Excellent. Bites, luckily. So, I think I'm kind of a stickler for lab safety, and I, really, believe me, I have made my fair share of mistakes. They could be painfully embarrassing and at the moment seem very devastating, but in the end it's really a teachable moment. It's very cliche to say that, but it's very true.
Is there anything else you wanted to add?
I guess I would just probably say I encourage scientists, if they haven't done so, to get involved with some sort of either outreach or science communication, just because it can really, even if that's not the field you want to go into, it can really serve as career building, and it provides great experience getting out into the community and talking to others about your work. That it's not something that comes easily for everybody, so I find it's a really great tool for people to kind of talk more about themselves, their research, and become a more well-rounded scientist.
Yeah, scientists tend to have a very rich internal life of the mind, and it sounds like a lot of your advice has been to look outward. Well, that's about all the time we have for now, so I wanted to thank you for your insights and conversation, Nicole.
Thank you so much for having me.
And thank you all for listening. My guest today has been Dr. Nicole Woitowich, and I'm Janet Lee. Please stay tuned for more episodes of Well, Don't Tell the Kids.